So let's talk about your redox reactions. So which metal is most easily oxidized? So in this case, you can simply go ahead and use table J to compare the ones, compare their reactivities. The one that is most active is going to be most easily oxidized. Which statement describes the electrons involved in this reaction? So we see that zinc is going from a charge of 0 to a charge of +2. That means zinc is losing electrons. So each zinc atom loses 2 electrons, and each cobalt atom in this case is gaining those 2 electrons. So zinc loses 2 and cobalt gains 2. What are the 2 oxidation states of nitrogen in NH4NO2? So the easiest way to solve a question like this, where you have 2 polyatomic ions, is to think about their individual charges. So ammonium has a charge of +1, and nitrite has a charge of -1. So that means when you set up the equation for this, nitrogen is X, hydrogen is +4 for the 4 hydrogens, and that should be equal to +1. So when you are solving for X, this should be 1 minus 4, that is -3. And then for the second one, this is X minus 4, because each oxygen is -2, and that should be equal to -1. So -1 plus 3, that's +3. So your answer is 3. -3 and +3. So oxidation number of copper changes from, so copper in this case is going to be, if you do the anti-crisscross, so copper is +2, and then copper in the products is 0. So it goes from +2 to 0. When a sample of magnesium reacts completely with oxygen, the magnesium loses 5 moles of electrons. How many moles of electrons are gained by oxygen? It should be the same. That's how redox reactions work. The electrons gained are equal to the electrons lost. Which statement describes the reactions in an electrochemical cell? So the oxidation is always at the anode and the reduction is always at the cathode. So remember the acronym that we used for this, NOx and REDCat. So oxidation at the anode, reduction at the cathode. Which particles are transferred during a redox reaction? That is your electrons. Which process can be represented by a half reaction equation? So out of all of these could be oxidation. Based on table J, atoms of which metal will lose electrons to the calcium ions? So we are looking at something that is more active than calcium. So just go to table J, look for the option that is more active than calcium. Which equation represents conservation of charge? So that means the equation where charge is same on both sides. So for example, if you look at 1, the overall charge on this side is 0. That means the overall charge on this side should also be 0. But what I see here is -1 and -2. That adds up to like -3. So it's not the same. So if you compare both sides, look for the side that is the same on both sides. It looks like option 3 is the one that is balanced. So when comparing voltaic cells to electrolytic cells, oxidation occurs at the anode always in both type of cells. Which statement describes the 2 types of reactions that occur in operating electrochemical cells? So we have spontaneous in voltaic and non-spontaneous in electrolytic. So here you go. Which process is represented by this diagram? So this is an electrolytic cell, and an application of that is electrolysis. So that is the dissociation of something, of a compound, into its individual ions or elements. So based on table J, which ionic equation represents a spontaneous reaction that can occur in a voltaic cell? So all you have to do is once again compare that if iron is losing in this case and magnesium is gaining, is that possible? can iron lose? So iron can only lose to magnesium if iron is more active. If iron is less active than magnesium, then it's non-spontaneous. And then here we see electroplating. So identify the electrode that attracts the copper ions as the cell operates. So because this is your copper electrode, let's first identify your anode and cathode. So remember, in case of an electrolytic cell or an electroplating, the thing that is getting electroplated is always your cathode. And the other thing is always your anode. So remember, oxidation occurs at the anode, so that means this is going to lose the electrons, and this thing is going to gain the electrons. So once it gains the electrons, it attracts the copper ions from the solution. So to answer this, you can say your cathode is going to attract the copper. So determine the oxidation state of sulfur and copper sulfate. So you can, if you just do the anti-crisscross, or if you just figure out the charges, because now you get +1 and -1, but sulfate is a polyatomic ion and it has a charge of -2, so that means copper in this case is +2. Write a balanced half reaction that occurs at the cathode here. So remember, we do not need to worry about what the bracelet is made of, because nothing's happening to that material. Copper is getting oxidized at the anode and it's getting reduced at the cathode. Okay, so we'll just say write the equation for the reduction of copper. So reduction means something is gaining electrons. So we have copper that is gaining the electrons on the cathode, and it's converting into the copper metal, which is getting deposited on the bracelet. Identify the subatomic particles that flow through the wire as the cell operates. So that is your electrons. And what is the direction of the flow? So remember, in this case, the electrons always go from anode to cathode. So in this case, they are going to go from, we are comparing copper and iron. So compare which one is more active. So out of copper and iron, iron is more active. So the electrons are going to go from iron to copper. So based on the change in intensity of the color of the copper nitrate solution, explain what happens to the copper ions as the cell operates. So what's going to happen here is electrons go from iron to copper. And so because iron electrode is going to lose electrons, it also loses the iron ions in the solution. And the copper electrode is going to get the electrons, and those electrons are going to attract the copper ions from the solution. So when that happens, copper gets deposited on the copper electrode. So copper deposits on copper electrode, and the mass of the copper electrode increases. Then state the purpose of the salt bridge. So remember, some people always get this wrong. The purpose of your salt bridge is to neutralize the solutions. And the way the salt bridge does that is by allowing the migration of ions, or the movement of ions. So even if you only say neutralize the solution, that should still be fine. So write a balanced half reaction that occurs at the copper electrode. So as we just said, at the copper electrode, we have copper ions that are combining with electrons, and they are becoming copper metal. Explain in terms of electrical energy how electrolysis reactions differ from voltaic. So because it says in terms of electrical energy, make sure you do not forget this. So you just have to say in voltaic, we go from electrical energy to, sorry, the other way around. In voltaic, we go from chemical energy to electrical energy. And in electrolytic, we go from electrical energy to chemical energy. Please don't write it like this, like write complete sentences. I'm just trying to go quick. Okay, using the results of the student's investigation, state evidence that zinc metal is more active than copper. So what you see here is that we have different solutions in each of the wells, and then we are putting the metals in those wells. So when you put copper in the magnesium solution, in the zinc solution, in iron solution, and in copper solution, nothing happens. That means copper is not reacting. But when you put zinc in the magnesium, zinc, iron, and copper solution, it doesn't react with two of them, but it does react with the other two. So you can say the evidence here is that copper does not react with any solution, but zinc reacts with iron and copper. So that's your answer.